Hopefully today you've been able to get a bunch of different value, a lot of value from the conference, and a lot of learnings from both internal staff from AWS and just across the board. My name is Dave Ward. I run product and engineering for a portion of Amazon EC2, specifically focusing on how we can help customers optimize their usage and cost. I also have here with me today the CEO of Cycle Computing, who's a great customer case study, really focusing on how they've been able to scale their costs as they scale their compute. Today, what I really hope to focus on and what I hope we're able to take away from this session is how we can help you to optimize your costs and your usage when you're leveraging AWS and specifically EC2. There's three main areas that we're going to focus on. The first one is really making sure that you use only what you need and effectively then paying only for what you use. The second is really measuring and managing the resources that you have. And the final one is really focusing on scaling opportunistically. So if you have batch computing or a number of other pieces, you can accelerate some of your workload in order to get even more throughput and save potentially even more. So let's first focus on using only what you need. In today's keynote presentation, we talked about the transformation between on-premise and the cloud. What you've seen is that many people try to predict effectively demand over time. And when customers predict demand in a way that is over what they need, it produces waste. And on the other side, if effectively you are over-predicting demand or under-predicting demand, you're basically in a situation where you'll wind up disappointing your customers or alternatively paying a significant amount for getting those resources, those instances, that storage drop-shipped to you or however you need to get it in time to really satisfy your customers. In the cloud, we've actually changed this model. You can now get resources when you need them, however many you need, and you can begin to tailor your business model to what those resources are. So let's start out with what are those three main levers in terms of using what you need. The first is focusing on right-sizing the cloud. What this means is actually leveraging various different models to ensure that you have the right resources, whether it's the right instance types, meaning server types, or the right type of storage in order to optimize your usage. The second is really focusing on the right pricing model. So with the cloud, we've provided a significant amount of flexibility, whether it's focusing on what type of utilization that you're going to have, whether it's a different type of pricing model, meaning you need a different level of flexibility, or alternatively focusing on the level of scale and elasticity that you need in your model. The final piece is really when you're running any service. So as an example, I run the Spot service. When you're running any service, you really need to monitor and manage those resources that you have so that you can hit the scale and hit the benchmarks that really matter to you. So when you're right-sizing your cloud resources, there's a broad selection. And the point of having this broad selection is that so you can focus on figuring out what that ideal match is for your use case. You want to ensure that you're fitting the resource to your application as opposed to fitting your application to those resources. And you only want to go up to that next larger instance size and pay more when you need more. What this means is that using EC2, you can select any one of these 16 instance types, ranging from the T1 Micro that has around 685 megs of RAM, all the way up to our M2 4X Large, which has 68.4 gigs of RAM. Or alternatively, you can focus on the CPU power and really try to focus on how much compute capacity or cores that you have relative to your overall instance itself. Another alternative is really optimizing your storage. So what this means is that we have two different classifications of storage. The first is S3, and the second is Glacier. All three of them are secure, flexible, low cost, scalable, and durable. However, there's one primary difference between these two different models. And that's really what type of access pattern do you need between them? Is it high volume and low latency, or is it high latency and low volume of access? So put simply, for S3, if you have something like images you're hosting for a website, or media that you're trying to encode, or any number of things where you're gonna want to access those objects on a very regular basis, S3 really serves as the best place to store that data. However, if it's something like tape backups that you use to run in your data center, or something where you really don't need that data very often, maybe it's a genomic run or something of that nature that you want to save the data in case you ever need to produce those results again without actually running the compute. So you have that one main lever there of choosing those two different models themselves. The second piece, though, is on the S3 side, there's a second model, which is, do I care about the redundancy? So by default, with S3, you actually have triple redundancy built into your object store. So that means the likelihood of losing that data is very low. We also offer an option called reduced redundancy, which costs, if the regular model costs 5.5 cents a gig, it turns into 3.7 cents a gig per month hosted. So what that means is that you can actually transition and pivot based on what your requirements are. Now, whenever you're dealing with S3, there's a couple of really important pieces to understand. We talk about monitoring usage, and the reason why is because it's potentially easy to go in there and misconfigure various pieces, because there's a bunch of different options. And so one piece you want to make sure that you're paying attention to is monitoring to make sure that there's no jumps in usage that were unexpected. Often what this means is that you may be logging out more information than you potentially want. The other piece that you want to consider, which is a best practice, is making sure that you have the right lifecycle policies. So lifecycle policies, the best way of thinking about this is you can set up some sort of state management associated with the data. So if, as an example, you care about having log files produced from your web servers stored in S3 for 2 weeks, and then after that time, you may want them so that you can go back and explain things to customers or research problems during different periods of time, but the likelihood of wanting it is much lower, that may be the perfect transition point to move that from S3 and into Glacier. So as a quick example, Illumina actually leverages both of these for large DNA sequences. So at the very beginning, when they're performing runs and actually storing output, they store their DNA sequences to S3. And then after they've given information to their customers, they store it in Glacier so that they have a permanent record of the run that they've performed. The reason why is because the compute capacity that they've run is actually absorbs the majority of the cost of their run. And saving it in Glacier is actually a great long-term answer to their problems. So at Amazon, at AWS, I really hope that out of Andy's presentation today, understanding that we've had 31 public price cuts since 2006, it really is in our DNA to try to optimize for costs. And one of the things that I think Andy may have been quoted by saying this, is throughout AWS, our pricing philosophy is you pay for what you use. As you grow larger, you reduce your costs. And if you're able to commit, you can reduce those costs even further. So we have 3 pricing models that are really based on those three different key points. The first is on demand. And by and large, this is what pretty much most people in the industry are familiar with. It's a simple hourly price. It gives you the flexibility to switch between any instance type, any region or availability zone, or any of those potential flexibility pieces. Typically what we see in the cloud is that people who are running their utilization between 0 and 15% tend to run on demand. So this means if I'm only going to use it for maybe 1 month out of the year, I'll consider running it on demand. If, as an example, it's something where there's super spiky load, or there's uncertainty about that load existing for a very long time, I'll continue to run it on demand. Or if I'm doing benchmarking or maybe some form of testing, again, on demand is a great pricing model for that. The second piece, and actually the third piece as well, begin to come more into play when we talk about customers who are planning to keep that workload in the cloud for much longer. Reserved instances are really focused on workloads that are more steady state. I say that with a grain of salt because any workload greater than 15% utilization that will stay on for any period of time and where you care about having that capacity available when you need it could be running in reserved instances. The way reserved instances work is that you pay a low one-time upfront fee, and then you pay a much lower hourly fee anytime you use those instances. There's multiple varieties of reserved instances, ranging from heavy to medium to light utilization, and effectively what each of them do is provide a way of saying, I plan to run X% utilization in the cloud. And by choosing reserved instances, you can save upwards of 72% off the on-demand price. So when you're comparing against running a steady state load, whether it's on-premise or in another provider or any other place, it's important to make sure that you're thinking about reserved instances, because any time that you're planning to run that for any period of utilization, this is really what's important to compare against. The other piece is there's built-in flexibility, and we'll talk about it more, but there's things like reserved instances, so that even though there's you're actually signing up for reserved instances, and there's 1 or 3 year terms, there's flexibility associated with your ability to take advantage of that. So when I say that there's 1 or 3 year term, it's important to understand what this means. So I mentioned that it makes sense to run reserved instances anytime you plan to utilize your instances more than 15% of the time. Now, one of the very important things to understand is that if you buy a 1 year reserved instance, your break even, the time at which it makes sense to buy that over on demand, is very early on. It's about 15% utilization for some reserved instances. After that point, that 1 year reserved instance effectively means that we will ensure you have capacity for the remaining period. So it's just, if you think about it like an option, if it was a financial instrument, you are reducing your cost anytime you run more than that. And more than that, you also are ensured that you have that capacity. The last pricing model to talk about is spot instances. And spot instances is a very unique pricing model. It doesn't exist anywhere else at this point. And spot instances basically provides you access to our unused capacity. So what that means is that we set a price based on supply and demand, how much excess capacity we have around and how many people actually want it. And you're enabled to bid on that excess capacity. So anytime the spot price goes below that bid price, you'll receive capacity. Anytime it goes above that bid price, your instance will actually be terminated. Now, there's obviously a trade-off, which is that you could potentially lose those instances. But for workloads like batch applications, things running in queue-based processing, things running where it's basically asynchronous jobs, there's really a lot of upside because you can actually receive upwards of 92% off the on-demand price. So the savings here is significant. As a quick example, for reserved instances, you'll find customers like Netflix or others leveraging reserved instances for things like their web application servers. And when it comes to spot instances, you'll find them more for back-end applications like either Vimeo, who does video encoding, or potentially another good example would be Cycle Computing, who's coming up later. So as a quick illustration of where these fit in, I mentioned that there's multiple types of reserved instances. So there's heavy, medium, and light utilization. So what we typically see is that a customer will run some balance of heavy, light, and on-demand usage for their steady-state workloads, those that are running, again, where they have to ensure that their capacity is available. And then for their back-end applications where they may want to accelerate their workloads, where they care about getting things done, or they've built in to their pricing model or business models ways of a reduced SLA or potentially accelerating the SLA is when they leverage a spot. So I'll grab questions at the very end. In terms of the reserved instance marketplace, the reserved instance marketplace was actually started about a year ago. And what it enables is a lot more selection for people who are purchasing, and for the sellers, it enables flexibility as business needs change. So taking a quick, zooming into the buying experience very quickly, the way that the buying experience works is that you can go into the normal interface where you purchase reserved instances, and you can say, I am looking for a reserved instance that's shorter than 12 months. and it will show you any options, whether it's a third party, another customer, or Amazon's, and it provides you the option to go off and purchase them. So anytime that you're looking in the reserved instance marketplace or just purchasing a reserved instance, you'll be presented with an option of purchasing from third parties or AWS. Now, if you look at the effective price with some of these third-party options, they're typically cheaper than the Amazon offering. And what this means is that, and they're typically at a shorter term, and what this means is that you now have the option of trying to really optimize your costs. You can potentially get a cheaper cost, potentially for a shorter duration, which means that if you need that flexibility for a shorter term, you can optimize for it. So the selection actually adds a lot of value and a lot of variety and selection to it. Since launch, we've actually seen a significant number of reserved instances go up, really to enable very specialized use cases. So let's talk about the seller side of this. So those specialized use cases tend to be when business cases change. So primarily, the use cases where change matters is when you're migrating between regions or migrating between instance families. And so what this means is that, hey, the latest and greatest new instance type has come out. I'm interested in taking advantage of it. What you can do is you can say, I no longer want this instance or this reserved instance, sell it, then you get cash in the bank, and you can go off and actually purchase another one. There's various levels of business needs changing. Another example is you want to host a SharePoint website for a 6-month period because you have a partnership that you want to actually set up and enable hosting for that period of time. Well, if Amazon or there's not a RI on the marketplace that meets that need, you could go out there and purchase a 1-year reserved instance. After that 6 months is up, you could list it on the RI marketplace and then actually recoup the remaining of your residual upfront investment. So from that perspective, we're actually, from the seller side, we're actually seeing fairly good pickup in terms of how fast RIs are sold. It's important to understand that when it comes to reserved instances, typically people are thinking of this as a capital investment. So unlike something that's selling on eBay where it may sell in an hour or two, it's something that may take a couple of weeks. But the flip side of it is that you do have residual value with your reserved instances. So for a moment, step back and think about the old world with on-premise. And when you think about on-premise, you buy a server from somebody, and you put that in your data center, and at some point, a better server comes out, and you're stuck with it. And you're stuck with it for a year, 3 years, 5 years, depending on when you amortize it from. Now you actually have the flexibility of potentially a shorter-term reserved instance, or alternatively, if you don't want it anymore because you have another business need, you can actually change it. So there's a lot of flexibility built into this model that you can't get anywhere else. Now let's turn our attention to measuring and managing any of your services running on AWS. So we provide a significant number of tools so that you can actually manage your AWS resources and manage your AWS costs. Some of those are Consolidated Billing, CloudWatch alerts, billing alerts, Trusted Advisor. There's third-party offerings, many more potentially coming down the pipeline. Our goal with these, and as Andy pointed out earlier today, our goal is to make it even easier for you to optimize your costs on us. We're always looking for ways of returning more value to you. So from that perspective, let's start off with Consolidated Billing. The goal of Consolidated Billing is really to focus on how we can make companies who have multiple departments more easily manage their bill. So typically what happens is we have some company, Company A, and that company has 14 different departments. Each of them wants their account totally independent, maybe have IAM users set up totally separately. And what that enables is for them to operate almost as though they're a separate business, to move independently, to move at the speed of innovation. And however, your procurement departments or other ones really want to focus on getting the lowest cost, optimizing utilization, managing all these other aspects that you only get at scale, and at the scale of combining everything across the entire business. So Consolidated Billing really tries to bridge those two gaps. It provides some level of easy tracking of the resources and bills. It provides grouping of your usage in order to get into new volume discount tiers. RIs are actually the pricing benefit for reserved instances is shared across all these different accounts. And additionally, if you receive AWS credits for any reason, those are actually shared across all those accounts as well. From a quick perspective on what type of detail do you get in terms of bill visibility and otherwise, here's a quick summary. So at the payer account level, this is the account, this is effectively the company view. You can see where the company is actually spending the bulk of its money. So if it's spending it on compute resources, then that would be highlighted as shown on the screen. Alternatively, you can actually break it down account by account. So you could say, Mahir, who happens to be a developer on one of our teams, or Sur Kim is another developer, and they have two separate accounts. I can actually drill into those accounts, or it could be the auto scaling group as an example. And I can drill in to understand what they're using, how many resources they're using it, and really hold them accountable and actually, again, do chargebacks appropriately. I can drill into those and actually say how much EC2 are they using, how much S3 are they using, and really kind of understand at a greater detail level what's going on. The second big area that we have that really helps you manage your resources is CloudWatch. Now, CloudWatch is our monitoring solution, and it provides multiple different pieces of information to really help you optimize your service. As you may have seen up on during the keynote today, Mailbox has some form of monitoring. Pretty much most services these days leverage monitoring, whether it's just to monitor your CPU and I/O, or potentially things like if you have an external API, how many errors does that API actually produce? So you can actually put custom metrics into CloudWatch as well. The goal is really to gain insights, set alarms, react immediately, really kind of manage your business as you need it, either on 1 or 5 minute intervals. You can get fairly complicated or sophisticated setups leveraging CloudWatch. You can integrate it into auto scaling, so you can scale up or down your resources on demand. And what this really enables, going back to the original point of using the resources as you need them, by having this information to know if you're underutilizing a particular instance or resource, you know when to scale up or down. You know if your resources are sitting idle. You know if your queues or your load balancers are becoming to be backed up, and so you can actually scale up reactively associated with any of that demand. So the other piece here is that it provides some level of diagnostic information, which is important. So a long time ago when I was a developer, I spent a lot of time diagnosing requests that were going through the system. And one of the things that I found out is that some of the requests that were coming through were big, meaty requests that took up a ton of the CPU on a machine. And yet, most of the requests that were coming through were much smaller requests that took up barely any. And so using a tool like CloudWatch, one of the things that you can do is split the actual number of instances that you're running. So if you have a disproportionate number of the smaller instance, a much larger, you could actually say the majority of your fleet needs to be that smaller instance size. And the larger, for larger requests, you only need maybe 3 or 4 or 10 or 20, whatever that number is, of the larger instance type, and really begin to put some affinity associated with some of these pieces. The other piece is that you want to manage your resource utilization. So with auto scaling, some of the things you can do is scale up or down. So I guess we don't have too much on it here. But in terms of scaling up or down, with auto scaling, you have a couple of different ways you can do this. You can either follow the sun, or you can potentially do it just based on CPU utilization or queue length, or a number of other pieces as well. If you're using this to do things like queue-based processing, then you can actually rebalance worker nodes based on other pieces in your architecture, such as potentially I/O if it's an I/O-bound job. So there's a number of different pieces here that really play into your ability to manage these resources. In terms of CloudWatch, there's one other really important feature in terms of managing your costs and usage, and that is actually billing alerts. So billing alerts is important for any person who's trying to manage their spend. You can basically set a threshold when you will be notified when you exceed it. So if, as an example, you say, I only want to spend $25K this month on AWS, you can find out very easily when you hit that threshold, and you can also monitor dashboards to determine where you're at relative to that threshold. At that point, it really helps you to understand and contain your costs, make sure that you're not doing anything that's making you concerned about what you're running. And if you want to take any actions, you can actually hook CloudWatch alarms up with other actions such as terminating instances or doing some form of notification. The reason why we don't automatically terminate instances or resources when you go above a threshold is because we could potentially impact your business and we don't necessarily know what you want us to do. But by linking these two really powerful actions together, you're enabled to do some very powerful things. Anything you can do through CloudWatch, connecting with SWF or connecting with key actions like terminate or start or other pieces, really enable you to really build some powerful applications. Another important tool that's actually fairly recent, and again, got a shout out today during the keynote, was Trusted Advisor. Trusted Advisor provides you a bunch of key metrics, and the easiest ways of explaining this is that it has a set of checks that it looks through. So it looks through things like, do you have your security group set up so that you're not opening up too many ports? Do you have a big set of idle instances out there? Are you over-provisioned? Sorry, are you under-provisioned on a number of instances? Meaning, is your CPU running at 100%, or if it's an application node, running at greater than 50%, or a DB node greater than 30%? You can basically, it has a number of checks in place. One of the most powerful ones are the reserved instance checks. So this basically is a way of enabling you to optimize your costs. And so far today, this is that figure that was actually announced earlier today. We've recommended more than $22 million in optimizations based on this tool. And so our goal with this is to help you run more successful. We believe that by helping you be more successful in terms of scaling your costs, that's going to encourage you to keep coming back and leveraging more, because then you can actually scale large and scale your resources as you scale your costs. Trusted Advisors available both at business and enterprise level supports, and there's a bunch of info on what tests are available through it on the website if you're interested. So as a quick high-level just overview of some of those cost optimization tips, you can see that on this bill in particular, it basically shows that you could save up to $125,000. It also points out a number of instances that are underutilized based on CPU performance, I/O, and network throughput. In terms of idle load balancers, meaning they're not getting much usage, et cetera. So by using this tool, it really can point out some of those low-hanging fruit that are really important and are often missed. And simply by doing a reminder, so each month you look at this, you can easily figure out how to optimize your costs and not get surprises at the end of the month. In terms of performance tips, that's another area we optimize here. So overutilized, meaning if the CPU is running too hot, or security group proliferation, any of these things that we notice actually create a performance detriment, we also point out in this tool. The last great area for optimizing your costs is this whole ecosystem that's emerging around this. So up here, I think I have 11 different providers that enable you to optimize your bill. What they'll do is you can basically create an IAM account for them, and they'll basically track your usage, and based on that information, they'll propose ways of optimizing your bill, give cost allocation, or ways of charging various departments, or multiple ways of breaking down your costs. There are great recommendation tools out there, and obviously it's an area where there's a lot of innovation happening. The next big area that it's important to cover as we talk about scaling your costs is really almost a new frontier that's emerged fairly recently, and that's really understanding how you can begin to separate portions of your architecture. At the very beginning, we talked about the ability to separate your front-end application servers and your database servers and those things that have to be running with those that can scale opportunistically. meaning you may be able to leverage 1,000 or 10,000 or more instances. So there's a couple different use cases that really make sense here. The first is really kind of speeding up your workload. So there's a classification of workloads where if you have a steady state that you hit, you could get a certain throughput and achieve results by a certain point, let's say a day. However, if you could accelerate that workload faster, there's more value to it. So for those people that have been developing for a while, you may remember when it used to take a day to compile. And you can imagine that compiling in an hour or maybe even a few minutes may actually accelerate the workload and actually provide a significant amount of value, relative to a certain cost. And so leveraging Spot, what you can do is run your base workload on reserved or on demand to achieve a certain throughput that's a minimum level of SLA. And then you can opportunistically leverage Spot in order to accelerate your workload. So some of the ways, and I don't want to steal too much thunder from Jason here, but some of the ways that we've seen this is actually where people who are trying to achieve large-scale results that could take years and years and years of work to perform, they can actually run more instances and accelerate that workload through. Alternatively, we've also seen this work in things like other customers' business models. So Vimeo is a great example of this, where they have a freemium model. So in their free model, they actually leverage Spot instances. And in their premium model, they have reserved instances. And then they have a minimum set of throughput that they ensure for their free set of the business, where you can actually try out their product and then accelerate with Spot opportunistically. So they're that enables them to achieve a significant savings, I think upwards of 50%. And there's obviously a significant other set of customers who are doing this type of workload as well. Another big use case here is where the result or the value of the result doesn't matter as much as long as you get it by a certain need-by date. A certain date where, at that point in time, your manager may walk over to you and say, "You're fired." So from that perspective, it's important to think about having a delayable workload. So if you're able to say, if I don't have the result done by this point in time, I'm going to cut over and ensure that I use on-demand or reserved instances, you may have some period of workload in there where you can use Spot as well. So a great example of this are genomics use cases, particle physics, some form of Monte Carlo simulations, things where there may be actually some fudge room in when you get the results back. So from that perspective, what we're seeing is that they'll actually perform huge Monte Carlo simulations, scaling outwards of thousands of instances to accelerate their workload that used to take maybe a month to perform, and they'll get it in less than a day. So it's really Spot in a nutshell is about choosing the maximum price that you're willing to pay for any workload. So often the biggest concern that I hear is customers are afraid of how much they'll end up paying for Spot. And the reality is that you're setting a maximum that you're willing to pay for it. So if you never want to pay more than the on-demand price for a Spot instance, we'll set your max price below it. And you'll always ensure that you'll never even run a single instance when that price is actually below that level. Now, the upside is you only pay the Spot price, which means that it's often significantly lower than your maximum bid price. And so you can get a lot of opportunity to optimize your costs. The other piece with Spot is that if you're ever interrupted, the other great consideration, customers are concerned about whether or not they'll have to pay for that last hour. And the reality is they won't. So anytime we interrupt you, you don't pay for that last hour. So at most, if you're checkpointing once an hour, then you'll be in a situation where you never lose more than that 1 hour of data. And so you'll never actually be out anything but time. The beautiful thing about Spot, though, is that at least if you think about that first use case, it does a couple different things for you. Think for a second, or consider for a second, a scenario where with Elastic MapReduce, which is a great way of leveraging Spot instances. It's built into the model. You can do a lot of Hadoop with it. And really, within EMR, there's two pieces. One is core nodes, which basically is where your HDFS tends to sit, which is where all your core data is. and then task nodes, which can accelerate it with tasks with worker nodes running on Spot. And in that scenario, we often see things that are almost linear scaling. And so let's imagine for a second that you have a cluster running 4 instances previously, and it used to take some period of time. Now imagine for a second that you could accelerate that by adding 5 more instances. So again, nonlinear scaling. The way it works out is that you've actually accelerated the workload so that it takes half as long. But in reality, just running some simulations, which I don't have up here, unfortunately, it could save you upwards of 20, 30% off the on-demand price just by accelerating that. So you're saving both time and money. So using Spot is an interesting way of kind of getting both that scaling opportunistically, but also getting the time savings as well. Again, the savings, just to quantify, I think on average we see roughly around 80% across the entire customer base in terms of savings, but we've definitely seen customers saving upwards of 92% off the on-demand price. And we've seen customers scale over 10,000 instances fairly easily, well, with some work, but easily taking advantage of all those resources and spinning them up fairly rapidly. So again, in terms of spinning things up, you have access via the APIs, the console, and many other resources. Just to kind of put some things out there to kind of jog your mind on what works well with this. Obviously, MapReduce I talked about briefly, so elastic MapReduce. Scientific computing, things like Monte Carlo simulations, batch processing. Basically, when I classify this, it breaks down into several different architectures. One tends to be queue-based architectures, where if it's ever interrupted, I can put it back on the queue. Tends to be idempotent, so that if I ever rerun a portion of those, that I'm not going to, or atomically fail is another way of saying it. So I can roll back a portion of that transaction so that anything that happened as I was performing that type of computing or analysis won't affect any other databases or any other state outside of running that workload. Alternatively, it works in scenarios like Elastic MapReduce or Hadoop. And then the last one tends to be more of a checkpointing type solution, where at some point you're actually saving the state of whatever you're working on and able to really be able to reload that at a later point. So a great example of this, so you may say that, hey, this is great, it's interesting, but I don't want to spend the engineering time on it. So in terms of, or it may not be applicable to me, I don't know if I would ever use that many instances. And so a great example of just someone playing around on a weekend, they wanted to go off and index a bunch of web pages, 3.4 billion web pages. And Lucky Oyster was actually one of those examples. And they did it for less than $100 and in 14 hours. So they're, again, saving both time, money, and doing some pretty freaking cool things that otherwise wouldn't have happened. And we've talked about auto scaling, just as a brief way of kind of mentioning how CloudWatch actually works with auto scaling. Again, the way that Netflix does this is based on aggregated CPU utilization. And so you actually see real graphs up here from Netflix on how they're scaling up and down their usage based on time of the day, when people are watching Watch instantly and looking at the website. And so leveraging these resources means that you're using what you need when you need them, and so hence you're able to reduce your costs. And then we've actually already talked about this in terms of auto scaling. And so just to kind of hammer home a couple of the different pieces, if you just run 100% of the time using heavy utilization reserved instances, you can see 63% savings. And then in the last example up here, if you start to leverage Spot, you can actually bring down your costs even lower at potentially 89% savings. So there's a lot of data on this slide. I think we actually make these slides available, so I'd encourage you to look over the specifics here. But by and large, if you can leverage both reserve, Spot, and on-demand at the right times, scaling up and down, you'll actually optimize your bill quite a bit. So with that, I want to give enough time for Jason. So if you want to join me up here. So Jason Stowe from Cycle Computing, one of our great customers.
Thank you, David.
Thanks.
All right, let me make sure this is on. Can everybody hear me in the back okay? Awesome, great. So I'm Jason Stowe. I'm from Cycle Computing. And given that I'm here in San Francisco, I guess it would be good to start by saying I'm here to recruit you. Basically, I'm here to recruit you to look at the kinds of advantages that you can get off of this class, specifically of Spot, of cost reduction that Amazon's enabling. So in the past, in our area in particular, and I'm here to talk a little bit about high performance, or more accurately, high throughput use cases, many areas of science have required massive amounts of computation in a pleasantly parallel way. And because computing is now so liquid and so inexpensive, we can actually do use cases that were prior not possible. These are use cases where users would normally have been limited by what internal capacity they could have afforded to purchase based on grants or based on corporate budgets, rather than asking the correct question. So today what I'm here to talk to you basically about is not rate limiting innovation. So essentially what we believe at Cycle is that a lot of use cases are shackled by a lack of access to variable compute. That dynamic computing and inexpensive dynamic computing that Spot enables allows us to do things that could never be done before. And in particular, this is shown off just by a simple analysis of the scientific method. So if you look at the way in which science is done traditionally, and this is how many things work both in corporate America and in research institutions, the first few steps of the scientific method that we were taught in grade school are only done once or twice. So generally speaking, you ask a question probably once, hypothesize maybe more than once, but generally less than 3 or 4 times, and do a corresponding number of predictions. And those are all based on surprises that you may find in the experiment, test, and analyze portion of this cycle. So essentially what happens in those sections, they're exceptionally compute intensive when it comes to computational science. And it doesn't matter if you're designing safer airplanes, trying to manage risk, attempting to find drugs that treat cancer. All of these areas essentially go through many iterations on the experiment, test, analyze portion. Sometimes tens of times, sometimes thousands of times, and in many Monte Carlo or sample-wide simulations, millions of times you're going through this little cycle. So any benefit that we can provide in cost and or scale give us a multiplicative time-to-result, cost-save benefit, and that enables us to do better science and do faster science. So if we democratize access to compute power, our supposition based on just looking at the way in which experimentation is done is we can have huge impacts. And what I'm going to talk to you about today are some of the use cases that have gotten a little bit broader adoption and broader coverage in the public media. We have a large number of public case studies around utility supercomputing, which is this concept of being able to grab tens of thousands of cores from AWS, because we can now do this at ridiculously inexpensive costs in order to solve real science problems. And this is not just in one industry. So if you were, how many people went to reInvent last year in Las Vegas? Okay, so all of you, if you're looking at AWS, I'm going to give a plug as a third party, you should go to reInvent. It's an awesome conference, had a lot of information about AWS services, and both technical and high level. But essentially, we had Johnson & Johnson, Novartis, Life Technologies, PacLife, and Hartford Insurance Group all talk publicly about how they're using Spot and EC2 in general to accelerate various aspects of the research they do, risk management they do, and the businesses that they operate. And we have a large number of clients that are both large and small, but 2 of the big 3 insurance and finance, 6 of the 8 largest pharma, et cetera, that are all using this class of technology to do real work. So today I'm going to basically talk about 3 of these. One of them is a newer case study. Some of the others are a little bit older, but effectively we have a startup. This was Nimbus Discovery, created a 50,000 core cluster on AWS. It cost about $48.28 an hour. So $4,828 an hour to run this across every public region of Amazon at the time. So we had Singapore, Japan, Brazil, both of the West regions, the US East and the EU. Australia was not there at the time. Running that massive simulation, it ran essentially a needle in the haystack problem. They were trying to find molecules that docked with a particular protein in an effort to discover new cancer drugs. I'm also going to tell you a little bit in a minute about a Big 10 pharma that ran a 30,000 core cluster in 9 hours for about $10,000. And we also, that one actually identified 3 new leads in the wet lab. So this was Novartis. They talked at reInvent. And this class of run would never have been done if they couldn't have fit that amount of compute power in that budget. And so being able to take advantage of Spot basically led to this run, which then led to 3 drugs that are now candidates for clinical trials, which is somewhat unprecedented. Basically, to be able to do 1 HPC analysis, or high throughput analysis in this case, and have that yield 3 scientific results that they would not have found otherwise is a huge benefit, and it justifies, you know, if any of those pan out, it basically justifies all the work, Dave, that your team has done on Spot. So from a practical standpoint, the other use cases we see are even big data oriented. So we had a research institution that did 1 million hours of compute against 78 terabytes of genomic data. This is actually a really interesting use case. So essentially they had a set of samples that they had RNA data, which is expressed genes. For induced pluripotent stem cells. So this is the thing where they scrape your skin cells and they're able to turn it into stem cells that they can then use, I thought originally, to treat you. But the actual use case is they want to replicate the disease you have in the petri dish so they can attempt to treat that rather than having to run experiments on you. And so in this use case, they basically were doing an n-squared comparison against all of these samples to create a lookup table so that users could say, all right, well, I think I've turned this petri dish into a neuronal cell. Based on the genes that were expressed in all these other samples I have, is that true? Is this on its way to becoming a neuron? And so the goal of that computation was basically to create this massive lookup table, essentially a dictionary of whether they were succeeding or not from a gene expression perspective. That 1 million hours is about 115 years. So if you had started a single modern core back in 1897, the year that computer was first used as a term to mean an electronic calculator, it would have ran through the entirety of the 20th century, World War I, World War II, Vietnam, Desert Shield, and ended in 2012, right around the time Gangnam Style came out. And that was done for about 19 grand, thanks to Spot. So our most recent utility supercomputer that I'm going to talk to you about today actually used 10,600 servers. So this is the equivalent of many of the Fortune 100s we work with have this amount of infrastructure in about a 15,000 square foot data center. So basically what we did is we provisioned a 10,600 instance cluster in about 2 hours. So normally this process would have involved, in the physical world, doing an eval on all the different vendors, figuring out what hardware you actually wanted to use, provisioning or building the data center space in order to be able to house this, worrying about power, cooling, et cetera, and then in the end, getting the equipment from the manufacturer, which would take a significant period of time to just rack, stack, cable, configure, burn in. And instead, all of that process of probably a year would be a typical time frame for that scale cluster, was done in about a 2-hour window. We then ran about 40 years of computing on it. This is the view from the AWS console. Our browser kind of had a problem with the table control here, so this is actually the only portion of the AWS console that rendered when you create 10,000 servers on your AWS account. So we did have a bit of a hiccup there with Chrome. And then this is our view, essentially, of the cluster. So we have whole sets of software that are designed to be able to weed out any kinds of errors that might be occurring on the cluster as we're building it. There's about 10,000 dots there on the right-hand side of this. So in addition to having a beer at the end of this, we bought a couple people Retina displays. Yeah, essentially this was a Big 10 pharma. They created this, ran 40 years of computing on it in 11 hours, and the net cost was $4,300, thanks to Spot instances. So this really does allow us to do classes of science. This run would never have occurred if they had had to actually do this in-house. This is, again, another form of science where because we get the cost compression that Spot gives us, we can actually do science that was just feasibly not possible before. And we essentially have sets of software that do this on a regular basis, are designed to manage the data associated with it, schedule the data across the various parts of the infrastructure that are running a very large-scale HPC environment. A lot of our users actually do very small runs as well, and we have a number of people doing genomics analysis that just at most uses 200 cores, and that gets a lot of science done for a very low amount of money. But generally, all of those people at some point or another accumulate enough of a data set they eventually want to analyze against all of it. And that's when scale and the advantages of being able to grab Spot at such inexpensive prices become really advantageous. So I'm not going to talk too much about our stack, but I will talk about how we bid for Spot. So essentially, we have pieces of software that would sit inside and alongside your internal HPC environment, and then be able to route a workload either internally or externally and do the data movement required to make that work. And essentially, on the external cluster, we generally have a use case where you have a bit of, and let me see if I can get this working. No laser. So we have a bit of on-demand execute nodes, following up with the I need this by a deadline use case that Dave had illustrated earlier. So generally our users want to make sure that they'll get the result back in a certain period of time, and then they use Spot to augment the rest. The reality is that that's a really special use case for two reasons. Normally you have to pick two in a kind of, here are three wonderful attributes, pick two of them. The advantage of Spot is that you can actually get the best of both worlds. You can ask the question at scale, get it inexpensively, and get it faster, all at the same time. So essentially what happens is your cost per core hour, on average, goes down the more Spot you acquire. So if you have 10 on-demand nodes that guarantee that the result will finish in a certain period of time, and then you provision 1,000 or 10,000 Spots to get rid of the rest of the workload as quickly as you can, your average cost per core hour goes way down because it's the area under the rectangle that you're paying for. It's the amount of infrastructure you have provisioned that you're paying for. And you get the result back much quicker. So instead of having a use case that's a small number of servers over a very long period of time, you end up with basically a very large number of servers in a very short period of time. And that's primarily a high throughput use case that's enabled. We basically check the job load on the scheduling environment in the cluster. We calculate the ideal size of it. We then properly price bidding based on input from the users, and then manage Spot instance requests in different regions based on where we know the data is and where we know the compute is available in order to run the workload. I guess lastly, the only other portion that's important about this is that Spot instances, you can lose them. So one other thing that is worthwhile to consider is essentially checkpointing. So when you decide to deploy workloads that are not stateless onto Spot instances, you generally want the run times of those workloads to be sub-hour. If you run for 2.5 hours on Spot and you have a half-an-hour job, you might get 5 jobs done but only pay for 4 of them, because you don't pay for the fractional hour that gets clipped. But if you have a 12-hour job and you run for 2.5 hours and it gets clipped, then unless you have some form of checkpointing available, that basically will cause you to waste time. Thankfully, there are a number of open source projects. We've done a lot of automation on our stack, but you can do this yourself using things like DMTCP, which enable you to essentially checkpoint Linux applications without having to recompile them. So those are the notes on essentially technically how we do this. If anyone has any questions, I guess we'll take these at the end. But for the time being, I'll give this back over to Dave, who's going to wrap up.
Excellent. Thanks, Jason. Just in conclusion, I think there's a lot of different components to how you can leverage AWS. You have your pricing model. You have right-sizing your application and really using what you need, and really the opportunity to manage and measure what you're actually using. And lastly, it's important that you're using all the resources available to you from AWS. There's a significant number of options that are available to you, and so we would strongly encourage you to evaluate them. So at a high level, we wanted to leave you at least with one architectural slide. There's a bunch of architectural slides that are up on our website, but if you look at this, you can see that there's multiple services that you can leverage together, and when you leverage these components together, you're going to truly optimize your cost. Especially if you can leverage those more custom attributes associated with AWS that don't exist elsewhere, such as spot instances or CloudWatch or a number of those other aspects. So again, there's make sure that you're paying for what you use, you monitor and manage your resources, and that you're scaling opportunistically where possible. So the last piece is it's important that you understand the resources that are available to you. Often we're in a situation where if you're in an internal IT environment where you may want to consider against on-premise solutions. So it's important that you're thinking about not only the cost associated with things, but the cost of innovation. So with traditional hardware, you are rate limited based on what hardware you have access to. If you fail, you're stuck with hard costs. It also reduces the amount that you can actually iterate and experiment and how frequently you can do it. And as you've seen with both Jason's presentation and hopefully with some of my own, that you can actually iterate far faster, such as some of those bio-life sciences companies that we've talked about earlier today. So with that, I'd really like to thank you for listening and open it up for questions for either Jason or myself. Yep.
And I lose the VM. Do you do any graceful shutdown, or do I have to be on my own to a checkpoint so I can restart from the same point?
So the question was, do we provide any automatic checkpointing or resources upon shutdown with Spot instances? So we have an option called Spot Labs, which is a private beta that we currently have. Spot Labs. And what Spot Labs is it actually has a number of features that haven't been released for general availability yet. And one of them is actually notification prior to interruption. And so what you can do is using an SNS notification, you can set up any form of checkpointing that you wanted to prior to shutdown.
But I have to do all the checkpointing and the restarting, right?
Yep.
Now, how do you decide the spot price?
How do we decide the spot price? So it's based on supply and demand is what it comes down to. So you can imagine that the birth of Spot came to the fact that we have varying levels of utilization during the day, the week, the year. And our goal is basically to run as optimally as possible so that we can optimize our costs and pass those along to our customers. So in terms of, because there's that cyclicality of demand, the way that the pricing actually works out is that the spot price will actually fluctuate as well as those factors change.
Now, can I see your historical spot price so I can
Yes.
what it might be?
Yeah. So you can see the last 90 days.
Yeah. We had, during one of the runs we did, there was a point in time where a 17-cent instance became a couple $100 because someone had actually bid that because they didn't want to lose the node ever. And we see that in North America is a little bit more cowboyish around its bidding than the EU, which only was like 50% more than the steady state or something along that line. I don't know what you guys see, but
it's definitely something that we've been working on, making sure that people bid rationally. Since prices are typically so low, some people think that they'll never get interrupted if they bid very high. And so we often email those customers and recommend them to lower their bids. But in an environment where the prices are so low, people sometimes just assume that it's never going to happen.
Yeah, it's not a replacement for on-demand. You need to use on-demand.
Is there information anywhere about what sort of volume, how big supply and demand are?
Yeah.
If you want to, you're looking into something very large scale, what lever spot is, the worry is that that scale alone will change the price. Is there information about that?
So publicly, we don't share any information about our capacity. There's probably some obvious reasons, like analysts are always trying to figure out how big we actually are. But privately, I would encourage you to actually come up afterwards, grab one of my cards, and we can work with you. So as you can tell, Jason's group was able to get 10,600 instances. We can handle scale.
Is that atypical? Did you get lucky?
No, actually, it's not like at all. What scale are you thinking you're going to be operating at? Okay. So let me just do some math. Yeah, so that's a couple thousand instances or 1,000 instances, essentially. We regularly spin up 10 to 20,000, 25,000 core clusters, our customer base does. And they don't contact us about it, and they don't contact AWS necessarily about it either. Well, so most of the time the clusters are up for at least an hour. Part of the interesting thing about Spot is we can actually, I mean, if you were to ask me where I think this is going, it's interesting because a lot of the work we've done has been large batches of computing. But the kinds of science that I think you could do now that you couldn't really do before are more around interactive use. So most of the clusters we do are up for at least an hour, generally 3 hours or more. But I think there's an interesting set of use cases around, and we're kind of working on this problem a little bit, is interactive use of like a 10,000 core cluster right now costs $90 an hour to provision. So I can give an individual researcher whose brain is worth far more than $90 an hour, a $90 an hour hammer that they can use to whack it away some really hard problems. And that used to be a very expensive endeavor. Getting a 10,000 core cluster was not trivially expensive. Now I can get it, use it for an hour and a half, turn it off, 2 hours, turn it off, and my total exposure was $180. So in terms of use cases, I think getting 10,000 cores is not hard. It went from the first time we did this back in 2010. It took a lot of coordination, and we notified people of when we were going to do this, and so on and so forth, to get the first 10,000 core cluster, which was with Genentech. Now it's not even thought about. But the interesting use cases, I think, are going to go from being batch-oriented to being more interactive use case-oriented, where I want to actually run simulations dynamically and ask questions of the simulation model in an interactive use case. And I think there's a lot of potential there. But again, it's kind of like the Spot enables kind of the similar to the horseless carriage versus the automobile. People thought that cloud is kind of like the horseless carriage now, where it's, you don't have to feed the data center, you don't have to clean up after its crap, you don't have to power and cool it and what have you, right? So they're treating it like what they did yesterday, but better, right? But I think a lot of the real stuff, and Spot is one example of this, is that you can do things that you just never could have done before. So in the automobile use case, that would be travel more than 50 miles, because horses died around 45. Right? If you want to travel more than 50 miles in a day, you couldn't use a horse. You had to use an automobile or a train or what have you. Having 1 million people commute into New York via car every day would also be equally impossible if there were 1 million horses involved. So I think cloud and AWS Spot instances in particular enable whole classes of use cases that we haven't necessarily touched the surface of. And I think the interactive one, where you do get a few terabytes of RAM for a very brief period of time and play with it, is going to be where the sexy stuff is. That's where the stuff we haven't thought of is.
So the reality is that we're in early days. We had more spiky customers where they would come in and kind of test the scale of our system, like Jason's group and others. Now we're just getting to the point where we're at large enough scale where not only do we have more capacity coming in from EC2 because it's a bigger business, but we're also getting to the point where our system is actually, we've kind of had to harden it because these big workloads have come in and we had to deal with provisioning 10 or 20,000 instances or whatever that was. And so we're getting to the point where these workloads are much more commonplace. So more than happy to work with you guys on giving you some advice, but my hope is, the other thing, I want to add one more piece there. It's important as you're thinking about bidding and trying to get this capacity. The old way of thinking in the cloud, we've actually already transitioned to the phase 2, and I think this is in part based on working with groups like Jason's, is that focus on bidding for cores or memory or something of that nature. Don't get stuck on one instance type because you're going to be able to get a lot more capacity if you can be more flexible in what you're bidding for. So.
Is the spot price, is it more driven by the
It's both. It's both. So if you look back in the forums, you'll see that at one point it was driven based on the supply of excess on demand because it was running a little bit thinner. But there's also scenarios where it's based on spot itself, where it's just purely contended. Mm-hmm. Mm-hmm.
Is there an API in terms of the charge done for the individual subgroups or departments?
There is not, but I know that we are working on
tagging. You could tag if you tag.
You can tag. It's just programmatic access to it. We're working on a CSV that you can actually get from the S3 bucket.
Yeah.
And that's in private beta now, but it should be released, I think, public relatively soon. So basically, you would just pull a CSV from S3 and then just parse whatever you want. Yeah.
You mentioned cloud-based
Sorry.
and trusted CloudWatch
Yep.
and trusted Lifecycle. Are they complementary? How do I know which one to use when?
So CloudWatch is mainly, in the context of cost, is used for billing alerts. So billing alerts is basically, there's a threshold that I want to be alerted based on, and you just want to be notified via SNS notification, so email or something else. Trusted Advisor is much more like someone that's auditing your entire usage of all the resources and literally has a checklist of here's all the things that you could be doing better.
It's more longer-term thing as opposed to an immediate alert.
Yeah, one is much more narrow in focus, and the other is looking across security and resource utilization and a bunch of other pieces.
You also mentioned auto scaling.
Uh-huh.
Does auto scaling use either of these, or does it have its own way of internally figuring out when you need to auto scale?
It uses CloudWatch. So all the value associated with CloudWatch, you can use that. So if you wanted to leverage custom metrics, you could leverage custom metrics in there as well.
We do huge transcoding stuff in the cloud. Before I want to be able to use the Amazon stuff. But one of the big concerns we had was transcoding workflow. You take a spot away. How to detect that? Or I know we use Azure worker roles and we can handle stuff like that.
Uh-huh. So the metric that I had last, and it's been a while since I ran it, was about 5% terminations per hour, which is relatively low. The length of time. Uh-huh. It normally is 1 minute minimum that you're going to get.
Right.
Yes. Yep. But it could be, It does right now, but it could be changed in the future. Yes. So what I would encourage you to do, I'm happy to connect with you, like the notification prior to interruption, we have a hook prior in our workflow where you can actually get ahead of it and do any of the cleanup that you need so you get more time before the actual notification happens. Yeah. That sounds great. Yep. So let's see, CloudWatch. No, this is like way beginning. So I think at a high level, in terms of CloudWatch, it has a bunch of different metrics pre-configured. You can also add in your own custom metrics. And so if you wanted to put in widgets or whatever, you could actually do that. So you can actually custom integrate whatever metrics you want. I think the example may have been that sometimes there's request volumes that come in that really will throttle I/O or CPU or something else. And if you have web server logs, you can potentially correlate, depending on what custom data you're putting in, with your actual basically CPU or otherwise metrics, and then you can say, hey, look, it's this request that's causing this pain, and then figure out how you want to route things based on affinity or otherwise. I think that may be the example. Is that right? Yeah. So it requires you to read through your logs and actually potentially put a custom metric. So we actually have a put API that allows you to put stuff into CloudWatch, and then you can aggregate that information so you can see in a graph as you go along. And I think there's actually plugins that do this for you already, but they're mostly third-party and open source on the web. Anything else? Again, if you're looking for life science, financial services, everything else, we've worked with Cycle quite a bit, and so they're great.
Thanks.
Let me know if there's anything else we can help with. Thanks.
All right. Thank you.